Hello, Algebra Scholars. This is section 5.6 on solving quadratic equations. A quadratic equation is simply a fancy way of saying a second-degree equation. And that's a little bit confusing because those of you that have studied Latin know that the prefix quad means 4, but in algebra, unfortunately, a quadratic equation is a second-degree equation. And we know that every second-degree equation looks like this. ax squared plus bx plus c equals 0. And this looks a lot like what we were studying last section, except for it wasn't an equation, it was an expression. Now it has an equal sign in it, and we're actually going to be solving it rather than just factoring it. And to solve second-degree equations, we need something called ZIPI, or ZPP, which stands for the zero product property. And the zero product property says the following very simply. It says if A times B is equal to 0, then either A is 0 or B is 0. If you're the idea here is if you're multiplying if you are multiplying two factors together and the answer is 0, the only way to have the answer to a product be 0 is if the first factor is 0 or if the second factor is 0. So let's see how this works. So the steps for using ZPP are here. There's just 3 of them. They're quite easy. First step is to get 0 on one side by itself, no problem. Step 2 is to factor the other side, and we just spent 5 sections working on factoring, so that shouldn't be hard. And then step 3 is set each factor equal to 0, and then solve. So here's a little example for us to get it started. X squared minus 9x minus 10 equals 0. Let me just point out to you before we start that there's now an equal sign in these problems. We're now solving rather than simplifying, rather than just factoring. So step 1 says get 0 on one side by itself, and hey, look, it already is. Step 2 is factor the other side, so now we need to remember our factoring. It's a trinomial with a leading coefficient of 1. We'll make a factor sum chart. Two numbers that multiply to -10 and add to -9. They're -10 and +1. Since the leading coefficient is 1, we don't need to rewrite the middle term and use grouping. So step 2 is factor the other side. We've done that. Check. And then step 3 says set each factor equal to 0. So x minus 10 is 0, or x plus 1 is 0. And perhaps we should add to our notes up here. Set each factor equal to 0 and solve. So we go back to our x minus 10, we add 10 to both sides, and we say x equals 10. We subtract 1 from both sides and say x equals -1. So the solutions to this are 10 or -1. Let's turn the page and do another 2 examples. So in the second example, once again, we have 0 all by itself, so that's a good start. We're then going to factor the other side. Now we need 2 numbers that multiply to -30 and add up to 13. I'm going to go with I was going to say -10 and +3, but that doesn't do it. How about 15 and -2? Those multiply to -30 and add up to 13. So there's our numbers. Let's rewrite the middle term. And we'll use grouping to factor it. So 3x times 2x plus 5 minus 1 times 2x plus 5. Binomial GCF? Yes, there is. 2x plus 5, and what's left? 3x minus 1. That's the factoring, and then the last part of ZPP says set each factor equal to 0 and solve. So we'll subtract 5. 2x equals negative 5, and x equals negative 5 halves. Add 1. 3x equals 1, and we see x equals 1/3. So those are our two answers to that example. And then in our final example we'll do, hopefully we see that this problem is a difference of squares. We're squaring 2x and we're squaring 3. So it factors into 2x minus 3, 2x plus 3. We have our product, we have 0. That allows us to set each factor equal to 0 and then solve. And we see that x equals 3 halves, or x equals negative 3 halves. And that's pretty much it for zero product property.